So we're into a new chapter here. We're into chapter 3, which is all about functions, which I hate because everything is about functions. Functions, and what we're going to learn today, like here, is what is a function and how you describe functions. And just a lot of different stuff about functions, just being able to talk about functions. So what is a function? So that's what this question is asking. Well, maybe it's just telling us. I haven't even read it yet. Figure 2 shows a relation between states and number of representatives each state has. This relation might be named a number. Well, I think we should be asking the question, is this a function or not? So what is a function? To me, a function is something where if I ask you a question about something, can you give me a direct answer? So here, what we're asking about is the states. We're asking the question, how many representatives does a state have? And so if I ask you the question, how many representatives does Alaska have? Can you give me a straight answer? Yeah, it has 1 representative. How many representatives does Arizona have? It has 8. How many does California have? 53, and so on. Every one of these states only has 1 answer to that question. So if I ask the question, you can give me 1 straight answer. So this is a function. And you compare that to, I think, the next one. You see you got a couple here. Well, actually, no, all of these as well. You look at all of these. If you ask the question, how many calories does a windy single have? Well, no, you're saying it has 470 calories. If it has 470 calories, it has 20 grams of fat, 21 grams of fat. The counter example is one further down, or maybe a few further down. Did I not copy the picture? I must not have. We need to go to the textbook. And go way back up to chapter 3. Oh, we're in chapter 2. We need to go down to chapter 3. Right here. This is what I wanted to copy. So see, this is a counter example to that. If I ask you the question, what is Dan's phone number? Dan's phone number is 555-2345. But if I ask you what's Colleen's phone number, there's 2 answers to that question. So if we're looking at this is not a function, because for every person, if I ask you about their phone number, you can't give me a straight answer. So some of them you can, but not all of them. It has to work for all of them. And if I ask you what is Colleen's phone number, you can't give me 1 answer. You have to give me 2 answers. And so for that reason, it's not a function. That's not to say that it's broken or that it's wrong. It's just to say it's not a function. You look at this one, this is a function because dog has 1 life expectancy. Duck has 1 life expectancy, and so on. And that's the same idea with these. You look at these, same idea. You look at these, same idea. They're all functions because each one thing over here only has 1 answer. Each one thing over here, actually here it's not true, is it? Because if you look at this 0.71, how much does a 0.71 carat diamond cost? Well, there's 2 different answers for that. There's 1575 and there's 1952. So this one is not a function because each of these inputs over here does not only go to 1 output. There's one of these inputs that goes to 2 different outputs. So let's go back to my problems over here and see, was that what we were looking at here? Yeah, I just didn't copy that one for some reason. I copied this one twice. Silly me. But yeah, that's what we're doing here. So if we wanted to write a definition of a function, how most people talk about a function is that each input has 1 output. That's the critical thing about it being a function, is that each input has 1 output. And so whether you're looking at it like this, or you're looking at an equation, or you're looking at it as a set of points, that's always what the idea is. So one thing that I guess I should point out about functions is something you see here, that 7-Eleven has a gas price of $2.72 and Shell also has a gas price of $2.72. So two different inputs are going to the same output, but that's not a problem for functions. That's still, you can still answer the question, what is the gas price at Shell? 2.72. What is the gas price at 7-Eleven? 2.72. So each input still only has one output. It's not actually a problem that two of the inputs go to the same output. So here's another one. This is just another way to represent a function. I mean, just by a list of points. So when we're looking at these points, I mean, they're just like we're used to, x comma y points. But we always think of x as the input and y as the output. So this is saying that, like, if we input 1 into the function, what do we get? 4. If we input 2 into the function, what do we get? 5. And see how we can always answer that question clearly. So this is a function. And let's go ahead and jump down to C, because C is like the counterexample to that. If we input -3 into this function, what do we get? Well, this is saying that if we input -3 into this function, we get 9. This is saying if we input -3 into the function, we get 8. So because of that, it's not clear. If we input -3, there's two different things that we're getting out. So that means that that is not representing a function. And then B, so B is a function, because you look, if you input 1, what do you get? 4. If you input 2, what do you get? 4. You input 3, what do you get? 5. You input 6, what do you get? 10. So every number you put in, you only get one answer. So obviously the trick they're trying to show here is that you get the same answer twice, but that's not a problem when you're talking about functions. That's still a function, because you're still inputting one thing and getting one thing out. And then actually the second part to this question, if it is a function, state the domain and range. So the domain and range are just different words for what we've already said. The domain is the input, is the x values. The range is the output, is the y values. And also just a little tip, because I want to point out, in college they called this the codomain instead of the range. I get that probably in college they just didn't think the kids were smart enough to, they just get confused between domain and codomain, so they changed it to range. I don't know. But in college they call the range the codomain. But anyway, so the domain is just what you're inputting. The range is just what's coming out. So for A, and they're just going to be sets in this case. So the domain is just going to be the set of the numbers we put in, 1, 2, 3, and 4. And then the range is just going to be the output numbers. So 4 came out of it, 5 came out of it, 6 came out of it, and 7 came out of it. And then with B, it's just the same idea. So for the domain, what did we put in? We put in 1, 2, 3, and 6. And what came out, so the range was 4. 4 came out twice, but if we're listing the range, we don't need to do it again. So 4, 5, and 10. That's our range. So that's extremely important, and we're going to be talking about that a lot more this section. The domain is what goes in. The range is what comes out. So now we're looking at equations. So equations are another way we can represent functions. So determine if the equation y equals 2x minus 5 defines y as a function of x. So I would say we should just really think about this. I mean, there's a lot of different ways we could draw it out and we could try to do it, but I think just think about it. Is what do we say a function is? A function is where you put a number in, you only get a singular number out. You don't get two different answers. So if you look at this equation, remember x is what we're putting in, y is what's coming out. And so if we look at it, if we put in a number for x, is there any possible way we could get two different numbers for y? I mean, no, right? It's like we're just going to put in we put in 5 for x. We're just going to multiply it by 2, which only gets us one answer. And then we're going to subtract 5, which only gets us one answer. So there's no way that you can get two different values for y if you plug something in for x. So that means that this is a function. Because for everything you plug in for x, you're only going to get one thing for y. And one tip is that if you're able to solve the equation for y, like this one already is, if it's already y equals something, and there's no like plus or minus or anything weird over here that's going to get you two different answers, it is a function. So that's the general tip. If you can solve something for y, it is a function. Another way you can think about this, which we might get into these in the later examples as well, is that if you graph this, what does this look like? So we should be able to graph a line at this point. I think we did that earlier in this section. So this has a y-intercept of -5 and a slope of 2. So the line looks like this. And if you look at this line, I mean, it makes it pretty easy to see that with x being your inputs and y being your outputs, for every one value of x, there's only one value of y that's outputting. And we actually kind of have a name for that. We call that the vertical line test. So if you're looking at a graph and you can draw a vertical line everywhere that goes through only one point, then it is a function. And so see how that's different compared to if you had a graph that was like this, which, by the way, the equation for that is y squared equals x. So notice how we didn't solve for y. And if we tried to solve for y, get y by itself, we'd have to have a plus or minus over here, which is giving us our two different solutions. And see how we can see that from our graph as well. Because if we tried the vertical line test, this vertical line is going to cross through two different points sometimes. And if it ever crosses through two different points, it's not a function. So y squared equals x, not a function. 2x minus 5 is a function, which we can see through all those various ways that we just said. So let's see. I was doing this while I was a bit distracted, so there might be some mistakes. So here, determine if the equation x squared plus y squared equals 1 is a function. So, well, there's a few ways we could do it. Have we talked about circles yet? We have talked about circles. So we should know exactly what this graph looks like very quickly off the top of our head. This is a circle with a radius 1. And based on what we just said about the vertical line test, if you draw a vertical line, it's going to go through 2 points. So this is not a function. And you can clearly see there, like, well, yeah, what I was going to say is this is something like, I mean, I guess I can say exactly what it is. This is like x equals 1/2. This is like y equals √3/2 or -√3/2. And we can just see that from the vertical line test if we know what the graph looks like. If we don't know what the graph looks like, we can try to do the thing where we solve for y and see how when we solve for y, just like on the last one, we'll subtract the x squared from both sides, and then you have to square root both sides. But when you square root both sides, you always have that plus or minus. So see how now if we plug in something like 0.5, we're going to get two different answers for y because we'll have the positive version and the negative version. And so that means it's not a function. And you can also notice how anytime you have a y squared, that's going to happen, right? So anytime you have a y squared, well, I was going to say anytime, but, there might be one or two cases where it ends up not being. So almost all the time when there's a y squared, it's not going to be a function. All right, so let's keep going. So this is what we were talking about earlier. This is the notation we would use. This is how you learn it. And this is so critical. This is so critical. It is all over the place. So they're giving us the function f of x, and they're naming it f of x. The only reason they do this is so we can name them. So if you have multiple functions, which we probably will later on, that you can name them. So here we're talking about the f function. So they say f of 3. So I think this is like a parallelism type of thing. Notice how it's f of 3. Instead of f of x, it's f of 3. So that means everywhere where there was an x, you're putting in a 3. So this is 2 times 3 squared minus 3 times 3. And that's what that notation means. Every time. You see, even when it gets crazier like this, all it means is whatever's in the parentheses, x plus 3, you're going to replace the original x with that. So we'll get there. So let's just do out this math. So what is this? 2 times 3 squared minus 1 times 3 squared. So this is just 1 3 squared. So that's just 9. F of x plus f of 3. Well, you're just kind of building it together. So what is f of x? F of x is 2x squared minus 3x. F of 3, we just did that. That's 9. 3 times f of x, well, yeah, you just do that. So 3 times 2x squared minus 3x. I mean, that's it. If you want to distribute, you can. 6x squared minus 9x. There you go. All right, so the next one, f of negative x. So I know it feels weird to like replace an x with itself, but like a little bit different. But that's exactly what we're going to do. We're going to replace everywhere where there's an x, we're going to replace it with a negative x. So we're going to have 2 times negative x squared instead of positive x squared. And then we're going to have negative 3 times negative x instead of times positive x. And then you're just going to do that out. So that's 2x squared plus 3x. Beautiful. So negative f of x, well, that just means it's negative that entire f of x, 2x squared minus 3x. And then that's it. We can distribute the negative if we want. Negative 2x squared plus 3x. F of 3x, so 2, again, replacing all of the x's with 3x. So 2 3x squared minus 3 3x. So you just replace all of the x's with 3x. Compare that to how we did that here, and here, and here. All exactly the same, just replacing it with different things. And so now we can simplify it. So 3x squared, how do you do that? Well, you just square both of them because they're just multiplied together. So we got 2 times 3 squared, so 18x squared minus 3 times 3, 9x. Beautiful. So now here, same type of idea, f of x plus 3. So you're replacing all of the x's with x plus 3 minus 3x plus 3. And now notice here, if you're going to square x plus 3, you're not just squaring the x and squaring the 3. You've got to like distribute that all out. So what is x plus 3 times x plus 3? Well, so it's a squared plus 2ab plus b squared. And then I'll go ahead and distribute that negative 3 now. Make sure you're watching and distributing a negative along with the 3. So what now? Now we'll just keep going a little. So we'll distribute this 2x squared plus 12x plus 18 minus 3x minus 9. Don't need those parentheses there anymore. And then just combine like terms. So we just have the 2x squared. 12x minus 3x is 9x. 18 minus 9 is 9. So plus 9. All right. Now this is a good one. You might recognize this if you're in some later math classes. If not, I won't spoil it for you. But let's go ahead and find it. So what are we doing here? Let's come down. So let's say, what is our function? Our function was f of x equals 2x squared minus 3x. And we want to find f of x plus h minus f of x over h. All right. So let's just do that. So we're going to go 2x plus h squared minus 3 x plus h. So just replace the x's with x plus h's. And then minus that entire function. And then all of that over h. All right, so that's the answer. But we shouldn't just leave it as that. We should simplify. So what is x plus h squared? Just like before. So that's x squared plus 2xh plus h squared. Let's distribute the 3 minus 3x minus 3h. And then let's distribute the negative here. So distributing the negative, minus 2x squared plus 3x. And then all of that over h. All right, let's see if anything beautiful will happen. Well, I already see something. These 3x's are canceling out. So let's distribute that front 2 and see if anything else cool is going to happen. That gets us 2x squared plus 4xh plus 2h squared minus 3h minus 2x squared, all of that over h. All right, well, look at that. So we have a positive 2x squared and a negative 2x squared. They go away. And now look at how everything on the top of the fraction has an h in it. So we can cancel an h out of all of those. And so we're left with 4x plus 2h minus 3. And that should be the answer to that one. So that's like just kind of long and complicated. But stuff like this honestly shouldn't scare you because it's just a whole bunch of stuff you know. It's just a whole bunch of little math rules. You just got to be careful and make sure you don't make mistakes and simplify it as much as you can. All right, so for this example, this is just more of like before. They mainly just want us to practice using the calculator here. So there are a couple tips I'd like to point out. So, well, first off, let's go to Desmos. So if you're in a calculator like Desmos, a lot of calculators will do this, but Desmos just shows it very clearly, that you can define functions. So especially if like we wanted to do f of a whole bunch of different values, this is very convenient where we can go that f of x equals x squared. And then now on the next line, we can just type in what is f of 1.234. And it'll just do it for us. And see, that's really nice because now if we wanted to just change what we put in, we could just like change it really quick and not have to go back and type in all the different stuff in the calculator. And plus now, since we want to do the same input, we could just write this down and be like, okay, this is 1.52-ish. And then we could just change this function and say, well, now we want the function as the 1 over x. And you see that just changes our output for us too, because we changed the function. And the other tip I wanted to show here is that sometimes on calculators, this just ends up being easier, that instead of typing in 1 divided by x, maybe you want to write it as an exponent. So you remember that fractions as an exponent are always to the negative power. So 1 over x is x to the negative 1. And so see how it gives us the same answer. And so I might not do that for fractions, but honestly, I almost always do it for square roots. Because what is the square root of as a exponent? Well, it's 1/2 or 0.5. And see, that just ends up being easier a lot of the times because like if I typed in something and then I wanted to do the square root of it, I'd have to like go all the way back to the beginning, and often it wouldn't put it inside the square root, or especially if you're trying to do cube roots. Just do it as a fractional exponent. That's something I've like always done. And you'll see that that's the same thing. So here we get 1.11. If we were to do the square root of x, that's also 1.11. So fractional exponents are square roots, negative exponents are fractions. And either way, it just means make x equal to that. So you see we're doing the same thing as if we did the square root of 1.234. Desmos is just making the notation and the typing easier for us. So now we're talking about finding the domain for a function. So remember what the domain is. The domain is the x values, or the values you're allowed to plug into the function. So but sometimes if you plug in a value, you'll get like undefined, right? So the domain is all the x values where you will plug them in and it will not be undefined. So the domain is the good x values. But think about a lot of times if you want to find the good stuff, if you want to separate the good and the bad stuff, you got to look for the bad stuff. So that's what you normally do in that's what you normally do when you're looking for the domain. You're looking for the stuff that's not in the domain, and then the domain is everything else. So what x values will cause problems when we plug them in? Well, before we even start the problems, I'll say there's 3 rules when you think about the domain. Today we're only going to talk about 2 of them. We'll get to the third one later in the year. So, and we should already really know these. So for the first one, fractions. What about a fraction gives you things that are undefined? Well, when there's a 0 in the denominator, when the denominator is equal to 0. So anytime you have a fraction and you're thinking about what is the domain for this function, you've got to say whatever's in the denominator of the fraction is not allowed to equal 0, is not equal to 0. So now I feel like we should do that example. So we know that x squared minus 4 has to not be equal to 0. And so from there, we just try to solve for x. So add 4. X squared cannot be equal to 4. Because that's kind of fun. When you have a not equals equation, you solve it just the same as an equals equation. So we're going to have that x squared is not equal to 4. And we're going to square root both sides. And x is plus or minus, or I should say is not plus or minus 2. And so see what we've done. We've looked at what x is not allowed to be. X is not allowed to be 2 or negative 2. Because if we plug that in for x in the g function up there, we'll get 0 in the denominator. And that is not okay. So what is our domain here? This is the basics of it, is that it can be anything except for 2 and negative 2. So we'll talk about how to write those better in a second. But let's go on to our second rule. What else could cause us problems? And so we did this earlier in the year, and we kind of said it was not a problem. But when we look at graphs, and we look at the graphs of functions, we're really only looking at real numbers, not complex numbers. So we want to avoid complex numbers. So if we look at C, what do we need to do to avoid complex numbers? Well, if we need to avoid complex numbers, whatever is inside the square root, has to be not negative, right? So we say it has to be greater than or equal to 0. And so that's what we're going to do here. We're just going to take everything that's inside that square root, 4 minus 3t, and say that that has to be greater than or equal to 0. And then you just get t by itself. So I would add this to the other side and divide by 3. So 4/3 is greater than or equal to t. And that's our domain for this one. So those are your 2 rules. Those are really the only 2 rules that we have so far. Again, there'll be a third one when we start talking about logarithms. But we're not there yet. Right now, when we're thinking about domain, we just have to look, is there a fraction? If so, the denominator cannot be 0. Is there a square root? If so, the inside of the square root has to be greater than or equal to 0. And so if we look at something like A, where just none of those problems occur, the domain here is that there's no problems. The domain can be anything. So how do we actually want to write domain? Well, there's a couple of ways that we can say. The kind of quick and easy way is to write this. So what this is saying is it's saying x, and then this symbol here means element of, and this symbol here, this r, this kind of bold r, is the symbol for the real numbers. So if we're writing that, we're saying x can be any real number. So that's a totally valid way to write the answer for that domain. And we can use a similar thing here, because here we said that x is not allowed to be plus or minus 2. But remember, with the domain, we're saying what is x allowed to be? So it's allowed to be anything except for those two things. So that's how we'll write it. We'll say that x can be anything. I'm not so particular about how this should look. Well, I'll say anything, but not plus or minus 2. Another way we can write the answers to this is with interval notation. I think we looked at interval notation earlier, didn't we? Because here, this is really the best way to do it when you write domain, is to write what your domain is in interval notation. So with interval notation, you're thinking from what to what. So let's start with C. So we already said that the domain is that t has to be bigger than 4/3, bigger than or equal to 4/3. So let's think, what's the smallest thing t can be? Well, that's what we just said. It has to be bigger than or equal to 4/3. So the smallest thing it can be is 4/3. You put a bracket on the 4/3 because it can be 4/3. And then what's the biggest thing it can be? It can go all the way up to positive infinity because it just has to be bigger than 4/3. There's no maximum. And so that is the great way to write the domain for that function, from 4/3 to infinity. And really, we should write all of those like that. So if you look at one like A, well, there's no restrictions. So what's the smallest thing that x can be? The smallest thing it can be is all the way down to negative infinity. The biggest thing it can be is all the way up to positive infinity. So anything from negative infinity to positive infinity. Here, it's a little more complicated, but you can still do the same thing. So it can be anything, first off, right? So the smallest thing it can be is all the way down to negative infinity. But then in that interval, where does it stop being okay? Well, it stops being okay at -2. So we're going to say it can be anything from negative infinity to -2, but then it cannot be -2, right? So we're going to put a parenthesis on the -2 to show that it cannot be -2. And then what else? There's other stuff. So we do a U. That just means union. So union means or. So we're saying that it can be anything from negative infinity to -2. Or what else? Well, it can be anything from -2 to 2, right? Because it can really be anything. We just have to show those gaps at those two specific numbers, at -2 and at +2. So we'll say anything from negative infinity to -2 is good. Anything from -2 to 2 is good. Anything from 2 to infinity is also good. You just have to include those gaps with the parentheses there. But that's how you'd write that domain. And then lastly, for D, you see D, we actually have two problems. So that's pretty interesting. Let's switch a different color so it looks cleaner. So we have two problems here. So the first problem that we have is with the denominator. So we have to say that that denominator cannot be equal to 0, which means that x cannot be equal to 5. So that's one problem that we have. But then we have the top square root as well. So we have to apply the second rule of finding domains, which is whatever is inside the square root, in this case 3x plus 12, that has to be greater than or equal to 0. And so you do that and get x by itself. Subtract 12 and divide by 3. So x has to be greater than or equal to -4. So think about what we're saying there. We're saying that x has to be bigger than or equal to -4, but then we have that gap at 5. So interval notation, we're going to say bracket, because the smallest thing it can be is -4, and it is allowed to be -4. And it can be anything, but we have to put the gap at 5, so it can be anything up to 5. And then we'll say, or it can be anything from 5 up to infinity. So see how we applied both of those rules there, with the square root saying that it has to be bigger than -4, but then we had to have a little gap there for the 5 because it cannot be equal to 5. All right, so we're talking about domain. I think this is a weird question to include in the domain section, but heck, they give it to us, so we'll do it. So express the area of a circle as a function of its radius. So, I mean, do we know the formula for the area of a circle? I think we should. It's a equals pi r squared. So I think that's all they're really asking. Maybe they want us to have us use function notation. So if I use function notation, I would say the area, I'll name my function a. It'll be a function of r. And yeah, that'll equal pi r squared. And then interesting, they're talking about the domain. So with everything we just said about the domain, this domain is all real numbers, right? Because you can plug in r, you can plug in anything for r, and it's legal. But what they're trying to get at here is that, like, this is real life. Like, we're talking about the radius of a circle. Well, I guess circles aren't real life. But the radius of a circle is like a distance. We're talking about the length of the radius of the circle. And a length of something can't be negative. Like, sometimes it does make sense to draw it out and, like, write it as negative. Especially with triangles and trigonometry sometimes. We'll get there. But, you know, in reality, you can't have a negative radius. So all they're trying to say here is that our domain is that the radius can be anything. Can't be 0, though, right? So that's why we put a parenthesis on the 0. But it can be anything right up to 0 all the way up to infinity. So we would say that that is our domain for this problem. And then, let's see, Chubb suggested we derive that formula. That's not a bad idea. I'm not sure if I've ever done that. So maybe we will. I don't know what we want to start with. But anyway, let's finish this last problem. So this is just some more function notation stuff. Very important stuff. This is like the problems we were just helping out with on Twitch. At least we're going to have to do that same type of stuff. But this is just some notation. So look at A. See how they just write it like this. I think that's a silly way to write it. I would never write that personally. I would just write what it actually means. This means f of x plus g of x. And so we just do that. So we just do 1 over x plus 2 plus x over x minus 1. And then we'll go ahead and common denominator. Just combine it, so see if our answer can be simplified and make it look pretty. So we'll do, like I said before, we'll kind of butterfly, multiply like across. So x minus 1 plus x times x plus 2 over those multiplied together. I think I've called that the smile before too. Just because I normally do that curved on the bottom. Right, and now you just simplify stuff. So we'll distribute the x. So we got x minus 1 plus x squared plus 2x. And then just combine like terms on the top. So x squared plus 3x minus 1. And see, there we can't even factor that on the top, which is what I'm used to when we combine fractions. But there we go. See, for f minus g of x, that's just the same idea. It's just subtraction. So it's going to be f of x minus g of x. So let's see what we can get out of our last answer. So everything's going to be the same, except for this is going to have to be a negative. So we're going to have to distribute the negative. So this step would actually be x minus 1 minus x squared minus 2x. And the denominator would be the same, because that's the only difference between addition and subtraction. So we're going to have negative x squared. See, x minus 2x is negative x, and then minus 1 over x plus 2 times x minus 1. And this is just a tip for people in general. Maybe this is better, maybe this is not. I kind of like this idea. I just don't like having my highest x be negative. So one thing you can do, and you can just shortcut this at, like, once you see it, but if you factor out a negative from this, so that becomes negative x plus 1. In other words, this flips around. You factor out a negative, so it goes from x minus 1 to 1 minus x. And then you factor out a negative from this, which just means changing all the signs. Then you can cancel out those negatives. So the tip is, like, you can change all of these signs on the top and then flip around one that has a minus in it. So make this 1 minus x instead. And maybe that's better. I think it's prettier because there's no negative x squareds. But it's definitely a little not pretty because this is a 1 minus x instead of x minus 1. Like, basically, you still have to have that negative there somewhere. It just kind of looks cleaner when it's there. But either way, I mean, I always think simplifying is up to personal preference, whichever you prefer anyway. So both of those should be right. So just continuing these ideas. I mean, notice it's just f plus g that you just add them. So here we just multiply them. And multiplying them is easy. Multiplying fractions is very simple because you just multiply straight across. So if we multiply f and g, the top is just 1 times x. The bottom is x plus 2 times x minus 1. Yeah, that's f times g of x. So I feel like I should write that this is just f of x times g of x to be clear. And then the same thing with here. We're just going to do f of x divided by g of x. We have to determine the domain as well. Okay, we can do that. We'll do that after we do this. So f of x divided by g of x. So we're dividing two functions that are fractions. So I'll write that out first, but then remember, how do you divide fractions? Well, I think one way to remember that is like, if you want to divide by 2, that's multiplying by 1/2. So if you're trying to divide by 2 over 1, that's the same as multiplying by 1 over 2. And so other people will say keep, change, flip. It's the same thing. But so if we're dividing by x over x minus 1, that means we're multiplying by x minus 1 over x. So we end up with x minus 1 over x times x plus 2. And that is the final answer. So lastly, we found all the functions, but we need to find the domains of these functions. So one thing we should say is that since f of x and g of x are like this, and we're using the f and the g function, one thing that has to be true for every one of these functions is that x cannot be negative 2 and that x cannot be 1, because that'll get us our 0 in the denominator. So that's one thing that's going to apply for all of these. X is not negative 2 and x is not 1. And you see here, we get that from the final answer too. But the idea is, even if we don't get that from the final answer, that still has to be part of the domain. And so maybe I'll write this one in interval notation, maybe not the rest because it'll be similar. But see, so here we're going to have like 3 different sections because we have 2 gaps. That's like a little fence post problem. So it can be anything from negative infinity to negative 2. And make sure you do them in the right order too. It always needs to be least to greatest. So negative infinity to negative 2. Or from negative 2 to 1. Or from 1 up to infinity. Those are the domains. You see, we're just saying everything except for that gap at negative 2 and that gap at 1. And let's see, b is the same thing. B is like the same denominator, so it's going to be the same situation. Even if you change it to that, see how when x equals 1, that's still going to get you the 0. And then what about these? I mean, same for c. But then this one is different. So we're actually going to look in the textbook for this to make sure that I'm saying it right, because I do still believe we have to have those same rules. So we can obviously see from the function that x cannot be negative 2. I believe that we still have to, even though it went away, we still need to say that x cannot be 1. Because look at right here, if x was 1, we'd be getting 0 in that denominator. So I'm still going to include that. And then look how now in our final function, we have a new thing that x cannot be. Because now in our final function, we see that if x is 0, we're going to be dividing by 0. Which is the problem. Which also makes sense because we can see that here. Because if this is 0, this entire fraction, the whole g of x function is going to be 0. So also, x cannot be 0. And I'm quite confident that that's how that works. But let's look in the textbook real quick to make sure that that's what they did. Because I know that's a whole big thing with composite functions. That you've got to make sure that it works for that inside function too, even if things cancel out. Let's see, this is where we are. So the domain of f of g consists of all numbers for x, which g is not equal to 0, that are in the domains of f and g. Well, so they're not even clear about it, but see how they do include the 1. because you have to just also exclude it's because the domain has to work for f and g too. Because like this is the heart of it. Like this is what you're plugging into. So yeah, like you do actually get this. You can't just simplify first and say that stuff just goes away. Which is weird because you want to, but you can't. So that was good. That was section 1. We'll get to section 2 on Monday. Well, no, I guess on Tuesday, actually, because on Monday we'll be doing calc. But I hope you'll join us back again for that one.